All right, today we are going to talk about section 1.4, which is rational expressions and equations. And really what we're going to do on here, the goal with these are we're going to simplify. And we're going to simplify by turning these into factors. Okay, so what is a rational expression? Well, a rational expression is anything that deals with a fraction. So if I had something like x to the 1/2, this is a rational exponent, okay? If I have something that looks like this, 3x over 5x, this is a rational expression because I have a fraction right here. And I don't have to have an x in both of those. I could have 3 over 5x. This would also be a rational expression. So rational expression, all this word rational is telling us is that we have a fraction. Okay, so if we look at this fraction that we have here, 24 over 9, we know that this reduces to 8/3. But the question here is why? Why does this happen? Well, what happens is we're going to convert this, so we're going to convert this into factors. Okay, so to do this, my factors of 24, I can use 1 and 24, I can use 2 and 12, 3 and 8, and 4 and 6. Those are all of my factors of 24. But what I want to do is I want to find a common factor with the denominator. So if I have 9 in the denominator, the only thing that I can do down here is 3 times 3. So if this is 3 times 3 and I want to find a common factor, I'm going to use this guy, 3 times 8. And so when we look at this, 3 times 8, I see now I'm multiplying. So if I'm multiplying at this point, so when you have multiplication, so when we're multiplying, we can cancel factors. Okay, so that's what I have here. 3 times 8, 3 times 3, I'm multiplying, so I can cancel my 3's here, and I'm left with this term, 8 over 3. And this is my most reduced form. And, you know, normally what happens is you'll see this, 24 over 9, and people say divide by 3, and we end up with 8 over 3. And so what's happening really when we're dividing by 3 is we're dividing by the greatest common factor. But really, truly, this is what it looks like. We're multiplying this through. So let's look at these rational functions and see if this applies. So it says, which of the following illustrates this principle, where I can cancel like factors? So here, what I have is I have x plus 1 and y minus 2 on the bottom. Obviously, those are not the same. But I do have these 3's on the outside that are multiplied here together. So these 3's cancel. And so what I'm left with is x plus 1 over y minus 2. So this does exhibit this principle of being able to cancel like factors. Okay? Now, if I look at this one, I have 3 plus x over 3 plus y. So this is a factor, and this is a factor. But I don't have, so there are no common factors. So this does not show us that we can cancel anything out to reduce this. You cannot go 3 and 3 and they cancel each other out. Over here, because we're multiplying, we can, but here we're not. Okay? If I look at this one, I'm multiplying. These are my factors. So this factor cancels with this factor. They're both x plus 1. So this does show that we can reduce. Okay? And then the last one. So this last one, I am multiplying when I have 3 times the x plus 1, but I have this plus 2 out here on the end. So because I have this plus 2 out on the end, I can't cancel out this common factor. Right? That would only work if it looked like this, x plus 1 over x plus 1, and then I have 2 x plus 1 over x plus 1. So I would have had to have this x plus 1 out front like I do in this first one. Okay, so here's another one where this principle doesn't work. So what does this say? This says never, never, never cancel terms. Okay, so these are just terms, 3 and x. 3 and y, those are terms, so I can't cancel. You can only cancel like factors. Okay, so go back and look at this example right here because it's gonna really help you as these get a little bit more tricky. Okay, so let's look at this next one down here. So this is not in factor form, but everything is multiplied. So the first thing that I want to check is it multiplied? And the answer here is yes. So now I can reduce. And I'm reducing by canceling like terms, okay? So if I look at this, and we did this with exponents, but I'm going to do this without using my exponent rules. So I have 3 in the top, 12 in the bottom. That means I'm going to have 4 left in the bottom, okay? 1x in the top, sorry, 2x's in the top, 1 in the bottom. That gives me 1x on top. And then I have 1 extra y in the bottom. So this is my reduced form, okay? Now, we look at this next one. I have this operation in here. So this is not multiplied. We do not have this multiplied together. This is not in factored form. So what do I have to do here? I have to make it into factored form. All right, so I'm going to factor the top, I'm going to factor the bottom, and I'm going to see what this looks like. So if I do this, on the top I can factor out a 3, and I'm left with 2 minus k. All right, so I can distribute, check this out, it works. So if I come down here to the bottom, I have a difference of squares. I can take the square root of both of these. So what I have is k plus 2 and k minus 2. So if we look at this, we see we have a 2 and a k, but our signs aren't the same. So I can change this top one by factoring out a negative. So if I make this, instead of a 3, make this a negative 3, then this changes my order to negative 2 plus k. I'm not going to change anything on the bottom. So k plus 2, k minus 2. Nothing on the bottom changes. Okay? Now, just to make this easy to see, I'm going to rearrange the order on this factor. And I can do that. And I can say k minus 2. All right? So k is still positive. I subtract 2. And then down here on the bottom, I have k plus 2 and k minus 2. Okay? Now, at this point, this is all multiplied together, and this is multiplied together. So now it's multiplied, so I can cancel these two like factors, and I'm left with negative 3 over k plus 2. Oops, sorry about that. Okay, let's look at number 3. So number 3 is very similar. I see that this is not in factored form. These are both in standard form. So what I want to do is I want to go in and I want to factor these two. So with this first one, I cannot pull out a GCF because this is not even and I don't have a p here. So I'm just factoring this trinomial. So I'm going to have 2p and 1p, and I see that this is 8 and this is 1. This is my positive 7 and my negative. Okay. In the bottom, I see I can factor out a 5p. So I have a GCF down here on the bottom. And what I'm left with here is p plus 4. Okay. Now, at this point, my top's factored, my bottom's factored, everything's multiplied together, so these cancel out, and I'm left with 2p minus 1 on the top and 5p on the bottom. All right. Okay, let's flip it over, look at the other side. So now we have an operation in here. Now, what we had over here, these were all, we ended up, after we put it into factored form, we end up with everything being multiplied. Well, over here, what we have this is two things that are multiplied together. So I can go ahead and I can cross-reduce before I multiply the rest of the fraction through. And that just makes it faster. So if I look at this, if I cross-reduce this, this becomes a 1, and this becomes a 2. So 7 goes into 14 2 times. I'm going to do the same thing this direction. 5 goes into 15 3 times. I have 1a here in the bottom, so this a is going to cancel with this a. So what I end up with is 3a times 1 over 2 times 1. Okay? Now, if you need to use this, write this out in more steps. If this gets you confused with all of my canceling on that, then you can write this out a little bit differently. So if I have 15a squared over 14 times 7 over 5a, if I want to do it this way and say, okay, this is going to become a 1 and this is going to become a 2. And I know this is multiplied. So now if I look at this, 5 goes into 15, this becomes a 3. And then a goes into a squared, this becomes an a, and this would be my 1 right here. So if you need to do this in a second step, then do that so that you don't get jammed up. So if multiply across either way, you end up with 3a over 2. And that's my final answer. Okay, so we look at number 5. What we have with number 5 is this is not in factored form. Okay, this is in factored form over here because I can't pull out another GCF on this. I'm done with this. So this is technically in factored form down here. But I need to put these in factored form. So hopefully you see that this is a difference of squares. So if this is a difference of squares, I'm going to have x plus 5 and x minus 5. And then down here on the bottom, I'm going to use a GCF, factor out a 2, and I'm left with x plus 5. And right now, I'm not going to do anything. Actually, I'm going to go ahead and just do this right now. So I see that this is 5 minus x, and I have here that I have an x minus 5. So if I factor out a negative 1, then this can give me x minus 5. Okay, so I did two things. I pulled out the negative 1, and I changed the order at the same time. So if I pull out the negative 1 here, I would have negative 5 plus x, right? So what I did is I rewrote it. When I pulled out this negative 1, I rewrote it so that it was already with my x term first. Okay. Now, at this point, I can cross-reduce. So I have this x minus 5 and x minus 5. But now I can also reduce up and down. I can reduce vertically, just like we have in the problems on the previous page. So this x plus 5 and this x plus 5 also cancel. So what I'm left with is 10 over negative 2. And this reduces to just negative 5. Okay, so I can cancel up and down, so I can cancel vertically, and I can cross-reduce when I'm multiplying. And the reason why this works is because if I'm multiplying, what I know is that all of this squishes together on the top, and it all squishes together on the bottom. Okay, all right, let's go down here. So dividing fractions. Remember, we're going to use the same thing we do with other fractions of keep, change, flip, if you still need to write that down. And what I have is 2 minus t divided by 8 times 6 divided by t minus 2. So hopefully what you see is you have a t and a 2, and those are in reverse order. So what I'm going to do is I'm going to factor out a negative on the top up here. So if I factor out a negative 1, this is going to give me t minus 2 over 8 times 6 over t minus 2. Okay, so now because everything's multiplied and this is in factored form, I can cancel these t minus 2's, and I'm left with negative 6 over 8, which reduces to negative 3 over 4. Okay, so number 7 looks super sloppy. And the reason for that is because we're going to have a lot of things that we need to put into factored form. So I'm going to put these in factored form as I change my division sign in here too. So this first one, I have no GCF, so I know I'm going to have 2x and an x, and it has to be 1 because that's my only factor. This is a negative 1, so this has to be negative and this has to be positive. Okay, now I can check it. 2x squared, I have a negative 1. I have negative 2 plus 1 is negative x. So we're good. All right, so now I come down here, and I have 2x and x. I see that everything is going to be positive. All of my signs are positive. I want 5, so this is going to be 3 plus 2 is 5. Okay, now I'm going to go ahead and flip this now. So I'm going to use this denominator down here first because that becomes my new numerator. And so what I end up with is 2x and x. I'm going to have opposite signs, but I want a positive 1. So this is going to be plus 3 and minus 1. So 3 minus 2 is positive 1. And then down here on the bottom, there's no GCF, but hopefully what you see is 2 terms, so I have a difference of squares. I can take the square root of this guy and the square root of this guy. So this gives me 2x plus 1 and 2x minus 1. Okay, so a lot of pre-work to get us to the point where we can start canceling things out. Okay, so what I'm going to do is I'm going to look at vertically first, and these terms are not the same, and these terms are not the same. right? I can't pull out a -1 because if I pull out a -1, then that makes my x negative and my 1 negative, and that's not the same. So that's why I can't pull that out. If I look over here, 2x plus 3 is not the same, and that's not the same. So I can't cancel anything vertically. So now I'm going to look at doing a little cross reduction here. So I have 2x plus 1 on the numerator and 2x plus 1 over here. So these two are going to go away. And then this x minus 1 doesn't work. 2x plus 3 with 2x plus 3, and then I have plus 1 and minus 1. So that doesn't work. Okay, so now I can multiply across the top. So what I end up with is x minus 1, x minus 1. So I have two of those. So because I have two of those, I'm just going to make this squared. And in the denominator, I have x plus 1 from here, and on this side, I have 2x minus 1. And there's nothing else that cancels, so I'm all done. Okay. Now, if we look at these last two right here, they look super sloppy. There's a lot of stuff going on, but what I want you to think about is we are going to rewrite this with just old school division. What I have is I have a rational fraction in the top divided by another rational expression or fraction here in the bottom. So I can rewrite this. Remember, a fraction equals division. That's all it is. A fraction equals division. So I'm going to rewrite this, and I'm going to say 10 divided by x minus 3. That's my top fraction. And then I'm going to divide, so I'm just using an old school division symbol. So I'm dividing by 5 over 2x minus 6. Okay. Now at this point, I see I have a keep change flip. So I'm going to rewrite this, 10 over x minus 3. I'm moving this to multiplication. I'm going to go ahead, I see that I have a GCF here in the denominator, so I'm going to go ahead and pull the GCF out. So I pull the 2 out and I end up with x minus 3, and then the whole thing is over 5. Okay, now at this point I can go in, everything's multiplied together on the top, everything's multiplied together on the bottom, and let's talk about this for a second. So over here, when I pull this 2 out, we know that when we are factoring something out, we use this parentheses because we want to test it by distributing back into the parentheses. So if you look at this, we have x minus 3 here in parentheses, but we don't have 1 over here. Well, technically, I can add parentheses to this guy because what I'm saying is this is my entire denominator. So this is my entire denominator, okay? And really, the whole thing is multiplied by 1. But when you have this and you're like, okay, well, this is in parentheses, but this isn't, so I can't cancel it. Well, that's not entirely true. I couldn't just randomly add parentheses up here because when I distribute, it needs to be, it needs to match my unfactored form. But here, since it's the whole denominator, I can add parentheses. So this is going to cancel out. This 5 is going to reduce with this 10. And so the whole thing here simplifies to just 4. All right, last one. So again, I'm going to write this with old school division, and I'm going to say x squared minus 100 divided by x minus 3 divided by 10 minus x over x squared plus 7x minus 21. Okay? So now I see that this is super sloppy. I've got all these operations in here. I need to put them in factored form. So this first term up here is difference of squares. So I have x plus 10, x minus 10, x minus 3 stays on the bottom. I can add my parentheses because it's my whole denominator if I need to. On the top, remember I'm flipping. So I end up with x. I'm subtracting, so I have 1 positive and one negative on this. So my factors for 21 are going to be, hold on, let me think about this. So I can't have 3 and 7, so 1 and 21, 3 and 7, I guess that's it, 1 and 21 and 3 and 7. So that's not factorable. 5, 6, okay. And then down here on the bottom, I'm going to have 10 minus x. Well, over here I see I have an x minus 10. So what I'm going to do is I'm going to say 10 minus x, but when I factor out a negative 1, this becomes negative 10 plus x. Okay, so what I have here is, let me go ahead and, I kind of messed this up because I assumed that was going to be factorable. So x squared plus 7x minus 21. Okay, so I see that this 10 cancels with this 10. So what I have is x plus 10, and then I have x squared plus 7x minus 21, and this whole thing is over negative x minus 3. Okay, now it doesn't matter that this negative is in the numerator or if it's in the denominator. That doesn't matter. Okay, so this, I guess, this is going to be my final form. I'm just going to write this on the top because I don't like those denominator or those negatives in the bottom. X squared plus 7x minus 21. Okay, so this is my, oh, sorry. This is my final form right here.